Okay, so now we're on to an example that involves stopping potential. And I hope that you, again, watched the video where I talked about what stopping potential is. And we're using that to calculate some things about the electron. So, or the photoelectrons that are being exited. So in here, we start off with our given information, and we're told, right, the stopping potential is 1.25 volts. All right? Perhaps it would be helpful to kind of maybe show an animation just to remind you what that is. All right, so this is an app from PhET called the photoelectric effect. And here you have a sodium metal right here. And we're going to just turn on this lamp over here, like that. And the lamp is shining on here and causing the photoelectrons to exit out here. If I increase the intensity, I might be increasing the current down here. And there's a battery here, which I can use to kind of cause these electrons to stop. So if I slowly adjust this and make this plate more and more, that's just making them go faster, more and more negative, I can cause these electrons to stop. And you may notice that there's a current right in here, and I'm adjusting it so that that current has become basically zero. So if I just make it, oh, not quite there yet, not there yet, maybe a little bit more. So there it is, right about like negative 0.8 volts. So that's the potential that causes the electron to just get here, but not quite get to this plate, and that's why there's not going to be any current. So all of their kinetic energy that they've lost is equal to the potential energy of this field. So going back to our problem, we're essentially assuming that the maximum kinetic energy, right, is equal to the potential energy. You can think of the change in kinetic energy equals the change in electric potential energy, which is equal to Q times delta V. And Q for an electron has a value of E, and the voltage, we just simply call it the stopping potential. So this becomes just simply E times V sub S. So K max is equal to E multiplied by V sub S. So in this case, if the stopping potential is 1.25 volts, then the kinetic energy, if you just rearrange and put the E beside the V, you get 1.25 electron volts of energy, which is really convenient. So this is how much energy those photoelectrons had as maximum kinetic energy. So we're going to be using that with other things like the mass of the electron, which is 9.11 to the power of negative 31 kilograms. The charge of an electron, which is just E, is 1.6 to the power of negative 19. I know it's negative, I just want the magnitude of it. All right, so the magnitude of that charge. And then we're going to calculate, what are we trying to find? We are trying to find the maximum kinetic energy, which we just found. That's 1.25. I'll call that part A. And then part B, we're going to need to find the maximum speed of these electrons. So that's the part that we need to do still. So if you recall from your mechanics, we know that kinetic energy is simply given by 1/2 mv squared. Since we're finding the maximum kinetic energy, then we're actually then finding the maximum speed. So rearranging for maximum speed, we will get the square root of 2 times the maximum kinetic energy divided by the mass of an electron. Okay, mass E. So we just need to plug things in here. But there is, maybe stop, solve it before I start answering it. Stop the video, do it yourself, because there's a common mistake that people make. Let's see if you do make it. Okay, so perhaps, hopefully you have plugged in answers in here. 2 multiplied. And the common mistake that people do is they just put 1.25 electron volts, and then they put the mass electron, which is 9.11 to the power of negative 31 kilograms. But you need to be very careful. The problem is this is in kilograms, and in order to find the velocity in meters per second, your energy must be in joules. So this is not right if you just simply plugged in 1.25. You need to get that energy in joules. All right? That's what we need to know. So maybe I'll just do this on the side. We need to calculate what this energy is in joules, so we have to convert from electron volts to joules. And if you recall, in 1 electron volt, there is 1.6 times 10 to the power negative 19 joules for every electron volt. So this will give you 1.25 times 1.6 to the power of negative 19 joules gives you 2 to the power of negative 19. Joules. And that's what we need to plug in here. So 2 to the power of negative 19 joules. We'll just shorten that a little bit here. So now we're just going to be plugging that into our calculator. And we get 662,629 meters per second. I'll just say 6.62 to the power, or 6.63 to the power of 5. 6.63 to the power of 5 meters per second. And that's the maximum speed. When you do problems like this, by the way, make sure that your answers make sense. Like, for example, if you ended up with a speed that was like over 10 to the power 8, then you know you're faster than the speed of light, and that's not possible. So just make sure that your answers make sense as you go through. Okay, that's it for example 7.